Hello student, in previous lecture we have solved an ordinary differential equation by using the numerical techniques Picard method. Now in today's lecture we are going to start our next third method to find an approximate solution of the given differential equation, that is Euler method. Euler method. Okay, suppose dy by dx is equal to f of xy is the given differential equation having initial conditions y of x0 equal to y0. Then to obtain an approximate solution of this differential equation, we want to integrate this from, or we can write this differential equation as dy is equal to f of xy dx. Now integrate from y0 to y1 and from x0 to x1. Okay, so if we integrate from y0 to y1, what is the value of y0 is x0, what is the value of y1 is what? x1. Then we want to determine the next value. What will be the value of y1 when x is equal to x1? So that's why we integrate from x0 to x1, and then what is the value of y0 to y1. So what is the integration of dy? It is 1 from y0 to y1 is equal to x0 to x1 f of xy dx. Now next, here if we put the upper and lower limit, you will get y1 minus y0 is equal to x0 to x1 f of xy dx. Now for 0 less than or equal to x0 less than or equal to x less than or equal to x1, we can assume here the value of f of xy is equal to f of x0 y0. So now since it is a constant number, here we assume here value of f of xy is what? F of x0 y0. So we can take this f of x0 y0 outside the integration and we'll get y1 minus y0 is equal to f of x0 y0 and integration from x0 to x1 dx. So this implies this is equal to y1 is equal to y0 plus f of x0 y0. Okay, now what is the integration of dx? It is x from x0 to x1 and it is equal to y1 is equal to y0 plus f of x0 y0. Now if we put the upper and lower limit x1 minus x0, so if we put h is equal to x1 minus x0, we will get the Euler formula to find the value of y1 at x is equal to x1. So y0 plus h f of x0 y0. So this is the formula to find the value of y1 at x is equal to x1. Okay, so x0, the value of y at x is equal to x0 is given and its value is what? y0. Now next our aim is what? We want to determine what is the value of y when x is equal to x1. So we can find the value of y1 by using Euler formula. Next, if we want to determine the value of y2, then what is the y2? y2 is equal to y1 plus h f of x1 y1. So this is the value when at x is equal to x2 and continue so on. For an example, what is the general formula for Euler method? The general formula is yn is equal to yn minus 1 plus h f of xn minus 1 yn minus 1, or in general you can write yn plus 1 is equal to yn plus h f of xn yn. So this is the general formula to to obtain an approximate solution of the given differential equation at any given values of x using Euler method. So now for an example, consider dy by dx is equal to minus y with y of 0 equal to 1, compute y of 0.04 where h is equal to 0.01. So if you observe, all the values are given here. What is given here? F of xy is equal to minus y. F of xy, this is f of xy. Also, I want to modify this question. Also compare with exact solution. All of you know that how to find an exact solution. How to find an exact solution? By using first year. Already we have learned how to find an exact solution of the differential equation in first year class. That is, variable separable is there, exact solution is there, homogeneous, non-homogeneous, linear differential is there, integrating factor method is there. Okay, so want to apply the numerical technique also, and want to compare the obtained solution with an exact solution. So here f of xy is minus y, h is equal to 0.01, x0 is equal to 0, y0 equal to 1. x0 is 0, y0 is 1, given h, and this is what? F of xy. So next we want to find x1. First step, what is x1? x1 is equal to x0 plus h. So it is 0.01. Because x0 is 0. So 0 plus 0.01 is what? x1 is equal to 0.01. Now what is y1? y1 is equal to y0 plus h f of x0 y0. So here y1 is equal to y0. y0 is what? 1 plus h is equal to 0.01 into f of x0. x0 is what? x0 is 0, y0 is 1. But what is f of xy? F of xy is minus y. Okay, so y1 is equal to 1 plus 0.01 into minus 1. F of y. So minus 1. So what is y1? y1 is equal to 1 plus 0.01, and therefore y1 is equal to 1.01. So this is what? y1. Now next, y2 is equal to, this is step number first. This is value of y1 and x is equal to x1, that is 0.01, and we want to determine value of y when x is equal to 0.01. Means what? Still we want to determine 3 steps. After 3 steps we can reach at the point x is equal to 0.04. Okay, so what is x2? x1 is equal to x2 is equal to x1 plus h. So it is 0.02, because x1 is what? 0.01, and if we add again h, you will get x2 is equal to 0.02, and y2 will give the value at x is equal to x2. So what is y2? y1 plus h f of x1 y1. Okay, so y2 is equal to h y1. y1 is equal to 1.01 plus 0.01 f of x1. What is x1? x1 is 0.01 and 1.01. y1 is what? 1.01. So if you simplify this, we will get y2 is equal to 1.01 plus 0.01 into, what is f of xy? F of xy is minus y. So f of xy is minus y, implies it is minus 1.01. Minus 1.01. 0.01 and therefore y2 is equal to 1.01 plus not plus if we multiply these two, you can use your calculator also. If we multiply these two, 0.01 into 1.01, we will get 0.0101. Okay, so now what is y2 here? Y2 is equal to 1.01 minus 0.0101. It is equal to minus 0.999. Okay, so this is what y2. Y2 is equal to what? 0.999. Now next there is one mistake in the calculation. There is one mistake, that is 0.01 into minus 1 is what? Minus 0.01, and therefore 1 minus 0.01 is what? 0.99. So what is y1? Y1 is 0.99. So we want to make a correction here. It is 0.99. Then here also one correction, 0.99. So here is also one correction, 0.99. Then so if we make a correction here, then it is 0.99. Then minus here, because it is minus 1 minus 0.09, it is 0.99 minus, this is equal to 0.0099, and if we subtract this, we will get 0.99 minus 0.0099 is 0.9801. So this is what? Value of y2. What? At x is equal to x2. x2 is what? 0.02. Now next we want to determine number 3, x3. What is x3? x2 plus h. So what is x2? x2 is 0.02, and what is h? 0.01. So if we add x2 plus h, we will get x3 is equal to 0.03. x3 is equal to 0.03. Now what is y3? y3 is equal to x2 plus h f of x2 y2. So y3 is equal to x2. x2 is what? y2 is what? 0.9801 plus h 0.01 into f of x2. x2 is what? 0.02, and y2 is what? 0.9801. Okay, so to simplify this, y3 is equal to 0.9801 plus 0.01 into what is f of xy? It is minus y. So it is what? Minus 0.9801. So to simplify this, y3 is equal to 0.9801 minus, if you multiply this, we will get 0.09801. So if we subtract this, 0.98 from minus 0.009801, we will get this 0.9703. y3 is what? 0.9703. So this is the value of y at x is equal to x3. Now next we want to determine last iteration, that is it will use us the value of y when x is equal to 0.04. So what is x4? x4 is equal to x3 plus h. So it is what? x3 0.03, and if we add h, we will get x4 is equal to 0.04. So what is y4? Y4 is equal to y3 plus h f of x3 y3. So y4 is equal to y3. Y3 is what? 0.9703 plus h 0.01 and f of x3 y3. Now what is x3? 0.03 and y3 is what? 0.9703. But what is our f of xy? F of xy is what? Minus y. F of xy is what? Minus y. So this is what? Minus 0.9703. So if you simplify this, you will get y4 is equal to 0.9703 minus 0.009703. So if you simplify this, you will get y4 is equal to 0.9606. So this is the value of y4 when x is equal to 0.04. So what is the answer? Answer is what? Y of 0.04 is equal to y of 0.9606. But we want to compare this answer with an exact answer. So what is an exact answer? To find an exact answer, we want to solve a given differential equation, or we want to determine exact solution of the given differential equation. Now, how to determine an exact solution of the given differential equation? There are various methods to solve a given ordinary differential equation. So, if you observe the given differential equation dy by dx is equal to minus y, it can be solved by using variable separable method. That is, you can separate the variable x and separate the variable y. So, if we separate the variable x and y, we will get y is equal to minus dx. Y is equal to minus dx. That is, if we take y into this side, dx into that side. So it is what? If we integrate on both sides, we will get log y or ln y or log y. So log y is equal to minus x plus c. Minus x plus c, or this can be written as y is equal to e raised to minus x plus c, or this can be written as y is equal to e raised to minus x e raised to c. Okay, if we put in place of e raised to c is equal to capital C, okay, since it is a integrating constant, y is equal to what? C e raised to minus x. So this is an exact solution of the given differential equation. The inverse of ln is what? T. हे कसं आलंय समजलं का? कारण की ln y is equal to minus x plus c म्हणजेच काय? If we apply e raised to ln is what? 1. So y is equal to e raised to minus x plus c. E raised to minus x, e raised to c. But instead of writing e raised to c, we put here capital C is equal to e raised to c. Now we want to determine this value of c by using initial condition. So what is the initial condition? Put x is equal to 0. X is equal to 0, then y is equal to 1. So if we put x is equal to 0, 1 is equal to c e raised to 0. So c is equal to 1. If we put c is equal to 1 here, y is equal to e raised to minus x is an exact solution. Y is equal to e raised to minus x is an exact solution. So now we want to determine y of 0.04. So what is y of 0.04? Y of 0.04 is equal to e raised to minus 0.04. So if we use your calci, we will get minus 0.04. It is 0.9607. 079 means what? 08. 079. 079. If we rounding given value, given number to 4 decimal places, answer is what? 0.0 0.0 79. So this is what e raised to minus 0.04. But if we round the given answer to 4 decimal places, since this is greater than 5, we can increase this digit by 1. So it is 0.9608. This is an exact solution of the given differential equation. So what is an error? In exam there may be a question like this: find an error, absolute error between true value and approximate value. So what is the true value here? The value that we have obtained right now is called true value. So what is the true value? Y of t is equal to 0.9608. It is a true value. And what is the approximate value? Y of a, that is we have calculated just now by the Euler method, 0.9606. So what is that absolute error? Absolute error is equal to 0.9608 minus 0.9606. So if we take a absolute difference of this number, it will be 0.0002. So this is what an error obtained if we solve the given differential equation directly. Okay. So if you observe, this error is very large. Now to reduce this error, we want to apply the modified Euler method. Okay, that is our next part, next lecture. That is apply the solve the given differential equation using modified Euler method. Take one more example. On Euler method. Suppose dy by dx is equal to xy. Dy by dx is equal to xy with y of 0 is equal to 1. Y of 0 equal to 1. Find y of 0.2 with h is equal to 0.1. And also compare with an exact solution. Also compare given solution with an exact solution. So now in this example, what is given? F of xy is equal to xy. F of xy is equal to what? Xy. Then what is x0? X0 is 0, y0 is what? 1. H is 0.1. Okay. So what is y1? Y1 is equal to y0 plus h f of x0 y0. And this will use the value at x1 is equal to x0 plus h, that is 0.1. This will use us a value at 0.1. So what is y1? Y1 is equal to y0 is 1 plus h 0.1 f of 0, y0 is what? Y0 is 1. So but what is f of xy? X into y. So to multiply these two numbers, answer will be 0. So what is y1? Y1 is equal to 1 plus 0. So y1 is equal to 1. Y1 is equal to 1 and x is equal to 0.1. But we want to determine value at x is equal to 0.2. We have to move to the next iteration. So x2 is equal to x1 plus h. So what is x2? It is 0.2. Now this iteration will give us a value of y when x is equal to 0.2. So what is y2? Y2 is equal to y1 plus h f of x1 y1. So y2 is equal to y1. What is y1? Y1 is 1 plus h 0.1 f of x1 x1 is what? 0.1 and y1 is what? 1. Y1 is what? 1. So if you solve this, y2 is equal to 1 plus 0.1. What is f of xy? Xy is what is f of xy? It is x into y. That is 1 into 0.1. But 1 into 0.1 is 0.1. So this is 0.1. 0.1 into 0.1. This is 1 plus 0.01. So if we solve this, we will get y2 is equal to 1.01. So this is the value of y2 at x is equal to 0.02. Or we can write this answer as y of 0.2 is equal to y of 0.2 is equal to 1.01. Now we want to compare this with an exact solution. So what is an exact solution here? Now given differential equation is dy by dx is equal to xy. So again you can separate the variable x and y. So how to separate a variable x and y? Just multiply dx to this side. So dy divided by y is equal to dy divided by y equal to x dx. X dx. So now variable separated, integrating on both sides. Ln y is equal to x square by 2 plus c. So if you simplify this, if we remove this ln by e raised to x square by 2 plus c, then simplify this, y is equal to e raised to x square by 2 into e raised to c. Now put capital C is equal to e raised to c. So what is y? Y is equal to c e raised to x square by 2. So this is what an exact solution of the given differential equation. But we want to determine the value of c by using an initial condition. What is given? X is equal to 0, then y is equal to 1. So if we put x is equal to 0, e raised to 0 is what? 1. E raised to 0 is what? 1. So 1 is equal to c. So what this implies? What is our exact solution? Y is equal to e raised to x square by 2. So this is an exact solution of the given differential equation satisfying the initial condition y of 0 is equal to 1. Now we want to determine y of 0.2. So what is y of 0.2? E raised to 0.2 square divided by 2. That is e raised to 0.04 divided by 2. So this is equal to e raised to 0.2. So if we find e raised to 0.2 by using calculator, we will get it is equal to 1.0202. 1.0202. So what is the approximate solution? The approximate solution y of a is equal to 1.01. And what is the exact solution? Exact solution y of t, it is 1.0202. So if we find an error, there is a very large error here. That is, error is equal to, absolute error is equal to 1.0202 minus 1.01. Then error will be 0.0202. So very large error. Now we want to reduce this error by using modify Euler method. This is our next lecture. We want to stop here for today.